Hi everyone. So today we're going to be discussing about definite integrals and more importantly integration by parts. So integration by parts is nothing but like essentially a formula, and using that you evaluate certain integrals. And there are multiple problem solving strategies or ideas that you should have in mind while solving integrals, and integration by parts is one of the most important ones of them. So I'm going to explain the entire process of how this integration by parts works, and let's begin. So this is a question from the Stanford Math Tournament from the year 2014. And in this video, we're going to be looking at solving definite integrals, and we're going to be looking at integration by parts and change of limits in integration. Then we have some book suggestions for senior math Olympiads, and at the end, a similar challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
Okay, so before we maybe jump onto this question, let's say before that, let's first discuss what a definite integral is and what an indefinite integral is. So if you ever have like an integral f of x dx without any limits, this is called like a indefinite integral, right? F of x plus c. You always have this constant of integration over here. And this is what we call an indefinite integral, right? I'm pretty sure you're aware of that, but just like stating it. But if we have certain limits, let's say from a to b, f of x dx, then this is what we call a definite integral. And you have no constant of integration over here, or I can just state this as f of b minus f of a. Right? This is what we call as a definite integral because it has a definite value, whereas an indefinite integral will be like a family of curves sort of a thing, because we have this constant of integration over here. And this thing over here is called the integrand. But anyways, leaving those things aside, they are just like standard stuff. Let's come on to the main thing, which is called integration by parts. Now again, I'm just giving like a little bit backdrop before we actually jump onto the real question. So let's really discuss the process of integration by parts, right? So, well, what is integration by parts? It is nothing but a technique used to evaluate certain integrals, and it is very helpful. Okay, it is used basically everywhere, especially in indefinite integration. It's almost used everywhere, right? Integration by parts is probably like a simple technique, but it is very, very powerful. And what exactly is integration by parts? Well, it just relies on a formula. What's that formula? The formula is the integral of u dv is equal to uv minus integral of v du. Right? So this is like a simple formula, very standard. And how exactly does this mean? How does this work? We will look with an example, right? We will analyze this integration by parts with the help of an example. But before that, let me just kind of give you a brief idea of what this u and dv etc. is. So u is what we call as the first function, right? And then whatever is left is dv. Okay, so I can just say this is anything that's left, right? Anything that's left in the inside the integral, that is dv, right? How do you determine the first function? You determine by the isolate rule, right? Isolate is, or let me just write it like this, isolate, right? Isolate rule. I is inverse trigonometric, for example sine inverse x, cosine inverse x, etc. L is logarithmic, so for example log of x squared is logarithmic function. A is algebraic, for example 5x plus 7. T is trigonometric, for example sine 3x. And E is exponential, for example e raised to the power 2x, right? These are basically what constitutes the isolate family. And how do you choose the first function? So this is the priority order, right? First function. So in a way, whenever in the question, if you see an inverse trig function, that will by definition be the first function. If there is no inverse trigonometric, but there's a logarithmic function, then that becomes the first function. If you don't have this I and L, but if you have algebraic function, that becomes the first function. If you don't have I, L and A, but if you have a trigonometric function, then that becomes the first function. And if you have none of these, then the exponential function becomes the first function. So basically this is the order, right? I is given the first preference. Let me just write like this, first preference, and exponential is given the last preference for first function, okay? Or first function, or what was that called? U, right? U is the first function. So let's kind of analyze this with the help of an example. Find the integral of x times sine x dx, right? I hope this works. I haven't checked it out yet, but I just hope this works. So again, the Eilate rule, right? Eilate rule. How do we use the Eilate rule over here? Eilate rule. Do we have an inverse trig function? No. Do we have a logarithmic function? No. Do we have an algebraic function? Yes. So take that as u, right? And whatever is left is dv. dv is nothing but sine x dx, right? So we have our integral u dv, right? U is x, dv is sine x dx. What was that? uv minus integral v du. So I know u, I know dv. So what is v? V is nothing but the integral of dv, which will be the integral of sine x dx. And we all know that that is negative of cosine x. Here you can just ignore the constant of integration, or we can put that at the end, right? So v is nothing but negative cosine x. Similarly, I need a du as well. Du is nothing but the derivative of u, so that becomes dx. So now I know that the integral of x sine x dx is uv, which is x times negative cosine x, negative x cosine x, minus the integral of v du. What was v? V was negative cosine x, right? And du is obviously dx. So the integral I is equal to negative x times cosine x plus the integral of cosine x dx, which we know is nothing but sine x, right? Plus sine x. The integral of cosine is sine, and the integral of sine is negative cos, right? I hope that I did that correctly. But okay, anyways, so this was plus c. So this is how you would find the integral of this by parts. If you don't want to do this by parts, you probably can, but it will be tedious. So therefore, whenever you see such two functions, you can be rest assured that integration by parts is a good strategy. So whenever you have integration by parts, figure out u, figure out dv, then immediately find out du and find out v. Once you figure out these four quantities, just apply this formula and then you're good to go. Okay, now let's just come back to this question. So they have told us that x is f of x times this e raised to the power f of x, and we have to evaluate this integral. So let me just write this below. What have they given us? They've given us that x is f of x times e raised to the power f of x. And we need to evaluate, or we need to find the value of the integral from 0 to e. So it's a definite integral of f of x dx. So maybe if I just plug in f of x as y, that will make writing it a bit easier. It does nothing else. But you see that x is equal to y times e raised to the power y. And you have the integral of y dx from 0 to e. And let me just call that as I. Right? I for integral. How do I do this? Like, this is not too bad actually. Like, when you think about it, this is not a bad situation at all. The only thing that kind of bothers me over here is this y dx quantity. I don't like y dx. No. If it was y dy, I would have been happy. If it was maybe x dx, that also works perfectly, yeah? So one of the strategies could be either forming x dx or forming y dy. How do I form x dx? Well, let's just try and maybe figure out how to form x dx. How do I form x dx? I could form x dx if I could write y as maybe in terms of x. To isolate y and write it in terms of certain x quantities over here, right? Y in terms of x. So here we have x in terms of y. X is the subject. Is it possible to write y in terms of x? It's clearly not. I mean, theoretically it is, using some weird stuff. But right now, getting it into a closed form and getting it into an integratable form is not easy, right? Writing y in terms of x is definitely not an option. How can you isolate y? The question that I'm asking is isolate y. Or make y the subject. You just cannot do that. You want to take log, you can take log. ln y plus y. What next? There's nothing you can do. Right? So forming this x dx is not an option. Can I form y dy? And it so turns out that I can. Right? I was integral from 0 to e of y dx. So I want to like form a y dy sort of a thing. What do I need to do? Again, just to remind you, x was y times e raised to power y, right? How do I form this y dy sort of a thing? I don't want like this dx. So what I can do is I can do something like this, right? Integral from 0 to e y times dx times dy by dy. So in a way like multiplying and dividing by dy. So I then becomes 0 to e y dy times this quantity dx by dy. And can we find dx by dy? Of course we can. We know that x is y times e raised to power y. Just differentiate this with respect to y. So the derivative of y times e raised to power y with respect to y is nothing but dx by dy. And that can be very easily evaluated using the product rule, right? So dx by dy becomes y times e raised to power y plus e raised to the power y. So our I, the integral, becomes 0 to e y dy times dx by dy, which is nothing but y times e raised to power y plus e raised to power y. And over here I've been making a small error. The thing is, this limits of the integral, they were with respect to x. So whenever you have an definite integral in general, a to b f of x dx, these limits b and a, upper limit and lower limit respectively, are with respect to this quantity x. So whenever you're changing it, you're now doing the integration with respect to y, you need to write the limits with respect to y. So watch how I do that. We had x is equal to y times e raised to power y. What did we have earlier? We had 0 and e as the lower and upper limits. So you see, when x tends to 0, that means that y tends to 0. That's pretty clear. And when x tends to e, it should be pretty clear that y tends to 1. Because when y is 1, the right hand side becomes e, and that's what we want x to be. So the new limits are from 0 to 1. So I then becomes 0 to 1, and whatever we had left, y dy times all of those stuff. Y dy times dx by dy, which so happened to be e raised to power y plus y times e raised to power y. Right? Correct. Okay, wait. And now this is workable. This is very much workable. So I then becomes the integral of y times e raised to power y dy from 0 to 1 plus the integral from 0 to 1 of y squared e raised to the power y dy. And let me just label this as, let's say, I1, and let me just label this as I2. So it actually happens that I is I1 plus I2. And let me just maybe analyze this I2 separately, right? It's the integral from 0 to 1 of y squared times e raised to power y dy. And again over here, what I'm going to do is I'm going to use integration by parts. Eilert rule. Do we have an inverse trig function? No. Logarithmic? No. Algebraic? Yes. So u becomes y squared. What is du? 2y dy. What is dv? Anything and everything that's left. E raised to power y dy. What is v? Integral e raised to power y. Great. So I2 is uv y squared times e raised to power y minus the integral of v du e raised to power y. Du is 2y dy. So I2 then becomes y squared times e raised to power y minus twice of y times e raised to power y dy. And this actually happens to be I1. So I1 plus I2 happens to be y squared e raised to power y minus y times e raised to power y dy. I just took one I1 to the left hand side. So what do we have over here? We have I is y squared e raised to power y minus the integral of y times e raised to power y dy. And if you're wondering why am I not writing the limits, I'll take care of it at the end. Okay, limits in definite integration doesn't really matter unless you're applying some property using them. And really, if you're only evaluating the limits to find out a particular value, you can just plug them in at the end. It does not matter. Okay, let's maybe call this as I3, and let's maybe try and evaluate what this I3 is. Right? So what is I3? Integral of y times e raised to power y dy. And again, I'm kind of ignoring the limits. I'll write them at the end. Do not worry. Okay, again, Eilert rule, integration by parts. We have an algebraic function u, y, du, dy, dv, anything and everything that's left, e raised to power y dy. V is integral of that, which is e raised to power y. So I3 is uv which becomes y times e raised to power y minus the integral of v du, which is e raised to power y dy, which we very well know is nothing but e raised to power y. So what was I? I was y square e raised to power y minus I3, yeah? So I becomes y square e raised to power y minus y times e raised to power y plus e raised to power y. So I then becomes e raised to power y squared minus y plus 1, and then I need to add the limits which go from 0 to 1. So let's just plug in 1 over here. You'll get e, 1 square is 1 minus 1 plus 1 minus e raised to power 0 is 1, 0 minus 0 plus 1. And when you figure that out, I becomes e minus 1. And that is your answer. So it so turns out that this integral from 0 to e of f of x times, I believe, dx is e minus 1. So we learned a very important technique of integration by parts today, and I hope I made that simple and easy to understand. And now you can use integration by parts in other questions of calculus as well. Okay, so moving on to certain book sessions for senior math Olympiads, we have Elementary Number Theory by David Burton, Problem Solving Strategies by Arthur and Chell, Functional Equations by Venkatachala, Problems in Plane Geometry by Sharigan, Elementary Number Theory by Sierpinski, Graph Theory by Harari, and Combinatorics by Brualdi. So at the end, we have a similar but challenging problem. So this is a little bit of a challenge problem because it involves recursions as well. So if in, the integral, is defined in this manner, then prove using integration by parts that in actually satisfies this recursive relation for all n greater than or equal to 1. So when we try this out, and again, you need to use integration by parts. And we try this out and let me know if you're able to solve it in the comment section. Until then, I'll see you in the next video. Thank you very much and bye-bye.
The programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.